Okay, chapter 4.3 is sample spaces and theoretical probability. So this is our last section, and we're going to start with event. An event is one possible outcome of an experiment.
That's a 1 or not?
That's a 1. So an event is when we're talking about one possible outcome of an experiment. A sample space is when you're talking about all the possible outcomes of an experiment. Well, I thought I was recording, but I wasn't. So an example of sample space for tossing one coin 2 times, we could get a heads and a heads and a tails and a tails, or a tails and a heads. Okay, so our next example is a sample space for rolling 2 dice. And so we're going to talk about our possible outcomes first, and we're going to kind of draw a visual picture of it, and then we're going to write the sample space after. So the first thing we're going to do is we're going to write on a die, there's the numbers 1 through 6. So we're going to write the numbers 1 through 6, but you need to leave space between each number because we have a lot to do between each number. Okay. Now, if we roll a 1 on the first die, on the second die, what could we possibly roll? Say it again. A 3. What else?
4.
4. What else?
5.
Yep.
6.
Yep. On the second die, we have the chance of rolling any number 1 through 6. Okay? If we roll again, we could roll a 2 on the first die. And on the second die, again, yep, we can roll any possible number on the second die. We're going to keep doing this, so keep doing this, and we'll be back in a second. All right, so this is what it looks like to visually draw out what we could possibly roll with the 2 dice, okay? The first time, we're going to roll a 1, 2, 3, 4, 5, or 6. The second time, we're also going to roll a 1, 2, 3, 4, 5, or 6. So now we're going to write the sample space for this problem. So if we start with the number 1, we could roll a 1 and a 1. Hold on, I want to use, bless you, I want to use a dash, not a comma, because I'm going to put commas in between. Okay, we could roll a 1 and a 2. We could roll a 1 and a 3. A 1 and a 4. A 1 and a 5. Or a 1 and a 6. Okay, so those are all our sample spaces for if we roll a 1 first. So then if we roll a 2 first, same thing. We could roll a 2 and a 1, 2 and a 2, 2 and a 3, 2 and a 4. So keep going on this and I'll be back in a minute. So this is our entire sample space for rolling 2 dice. And we're going to use this information after we talk about the next definition. So our next definition is theoretical probability. Okay, so theoretical probability is a formula. And this little sign here just means the probability of an event occurring is the number of favorable outcomes over the number of possible outcomes. So probability is going to most often be written as a fraction or some kind of percentage or decimal. So let's say we're going to use our dice rolling sample space above. Let's say, what is the probability of rolling a sum of 7 with our dice. So I'm going to first look at our number of possible outcomes. So we have 6 going that way and 6 going this way. So we have 36 possible outcomes. Okay, so my denominator is going to be 36. So out of 36 possible outcomes, how many dice rolls add up to be a sum of 7? So, for example, 1 plus 1 is 2. So I need to find 2 numbers that add up to equal 7.
All the ones in the middle.
6 and 1. 6 and 1. Yeah. Okay, so those are the only ones that could possibly equal 7. So how many is that? 1, 2, 3, 4, 5, 6. Okay, so the probability, I'm still using a highlighter, hold on. Probability of rolling a sum of 7 is 6 out of 36. Or if we reduced it, good, 1 out of 6. So that's our chance or our probability of rolling a sum of 7.